Hello and welcome to a new Discovery Channel series, paintballing in the protected wildlife sanctuary.
Today we're going to teach you how the paintball gun works and the physics of paintball.
In the protected wildlife sanctuary. Damn. Before we go out into the wildlife sanctuary, we have to explain to you how the paintball gun works. Here's the paintball gun. The paintballs are attached to the top and they come in through the top of this into the barrel, and then they're shot out of the barrel. Attached to the back is a compressed air cartridge of CO2. The CO2 is usually at about 600 to 900 psi. PSI is pounds per square inch, which means that there is 600 pounds per square inch. This is a 20-ounce canister, so that's about 30 force on the CO2. Other paintball guns use highly pressurized air, which is a little more high quality because it's at 3,000 psi. We don't have a very big budget, so we're using CO2 for right now. The way the paintball gun works, the CO2 acts to push the bolt backwards whenever you pull the trigger, and when you let go of the trigger, the bolt shoots forwards because it wants to be in the normal position right here, where it is right now. So watch when I shoot the bolt. As you can see, the bolt is moving when I shoot the paintball gun.
In some of the higher end paintball guns, there's an electric circuit board, as you can see right here in the handle. Here there's a 9-volt battery, which helps the bolt with more kinetic energy, thus helping it fire faster, and some of them even have automatic firing. For this to work, you need to understand Ohm's law, which is V equals IR. Voltage equals current times resistor. There's always going to be a voltage difference in order for this gun to shoot, and that 9-volt battery does a lot to make this thing a powerful gun. I'd watch out when you're out there if I'm shooting this.
Before we go out to the field to shoot some protected animals, shoot some birds, we're going to explain to you some physics of how the ball moves. The first is the physics is horizontal projectiles. The way horizontal projectiles work is this. The horizontal movement of the ball is independent of the vertical movement of the ball. That means that if you shoot the ball this way, it is going to fall at 9.8 meters per second vertically at the same time as it moves horizontally. This can be exhibited by seeing how a paintball moves. If I were to drop this ball and shoot it outwards at the same time, they will hit the ball at the same time. They hit the ground at the same time. As you can see, this exhibits the independence of the horizontal and vertical movement of the paintballs. That way, the shooter can calculate the vertical movement in their head instead of having to calculate the combined forces of the two on the paintball. This demo is going to exhibit horizontal projectiles on a scarecrow. Yes, it is a scarecrow. Watch what happens when I shoot the paintball. Oh dear. Looks like it's falling at the same time as it's moving sideways. Oh, a scarecrow's moving. Must be some wind.
The next important part about hunting these game here in the protected wildlife sanctuary is sound waves. We don't want to scare off any animals, so we need to understand this concept very well. When you shoot a paintball, you hear the sound wave because a longitudinal wave, or sound wave, is moving at 340 meters per second. When we're shooting these guns, we want to make sure that we hit the target on the first shot, so that way the sound doesn't scare them off if we have to shoot them again. That's why this concept is so important when hunting. Another thing to do with sound waves is the Doppler effect. When I'm moving away from you, as I am now, you're hearing the sound less frequently at a lower pitch. But as I move towards you and shoot, you're hearing it at a higher frequency and at a higher pitch and more often. Let's go try out this technique on some of the bigger game that we find out here in the protected wildlife sanctuary.
Dude, I think you shot my wife. Hey dude, I don't remember any fences coming in here. Did we hop fences to get in here? Like, did we do that?
I don't think we did we?
I don't know, but there's a fence there.
Shit.
That's kind of weird.
Here we are now, folks.
Let's see if we can hit this red-tailed hawk on the first shot so he doesn't hear me after that. By then it'll be too late and he'll be gone. I think he knows we're here because he can hear the sound waves moving at 340 meters per second. I don't know if we've gotten him.